Good morning, children. In aim number 5, we have learned how to solve system of simultaneous linear equations. Now, using that knowledge, now in aim number 6, we are going to solve verbal problems. These verbal problems related to, mainly we can observe, related to numbers. And related to money. Third one, related to fractions. And fourth one, related to digits. And boats and stream problems also. Boats and stream problems. But in this aim number 6, we are going to see these three models only. Verbal problems related to numbers and related to money and related to fractions. Now, to solve these verbal problems, some steps need to follow. In that first step is, we have to read the problem carefully and identify unknown quantities. In the first step, identifying unknown quantities. This is the first step. In these problems, we can identify two unknowns mostly, because of we are learning linear equations in two variables. That's why only two unknowns we can identify. Let unknowns be x comma y. And in third one is forming of linear equations in two variables. That means establishing of the relation of the variables and the known points in the given problem. So the third step is forming of linear equations. Forming of linear equations. Now, fourth step. In aim number 5, we have learned three methods. Now, we have to solve these linear equations using any one of these three methods. So that the fourth step is solving of linear equations. Solving of linear equations. And the fifth step, verification. Those unknown quantities satisfies the condition in the given problem or not, we have to verify. That is the last step. Whatever the type of the problem, either it is related to money or fractions or numbers or digits, these 5 steps will be involved in it. Now let us see one by one model. Now first example I am going to take related to numbers. Example 1. Now see, one problem is given there. One number is greater than thrice the other number. One number is greater than thrice the other. One number is greater than thrice the other. One number is greater than thrice the other number by 2, and 4 times smaller number exceeds greater number by 5. Find the numbers. It doesn't conclude. Again, one number is greater than thrice the number by 2. First let me write the total problem. And 4 times smaller number exceeds greater number by 5. Exceeds greater number by 5. Now see once. One number is greater than thrice the other by 2, and 4 times smaller number exceeds greater number by 5. Now using this information we have to find those two numbers. Then find the numbers. Find the numbers. This is the problem. Now how to solve it? Here how many numbers are involving here? 2 unknowns. One number is greater number, other number is smaller number. Now using the given data, we are going to establish the relations which are known as linear equations in 2 variables. So that solution for this problem is, and once remember this one, solution. And what is given there? Let the greater number be x. Greater number is equal to x. Smaller number is equal to y. If you read the first sentence in the given problem, what do you understand? Greater number, one number is greater than thrice the other number by 2. That means x is equal to thrice the number and by 2. That means what do you understand? And it exceeds greater number is 3 times of the smaller number and plus 2. This, let it be equation number 1. Now by reading the second sentence in the given problem, what do you understand? Smaller number exceeds greater number by 5. That means what is smaller number here? y. 4 times the smaller number, that is nothing but 4y is equal to exceeds greater number by 5, that means x plus 5. The difference between the 4y and x is given, and the difference between the x and 3y is given. Again, I will say, let the greater number be x, let the smaller number be y. Now, according to the given data, we are going to establish we are going to form the linear equations. First one number, that is greater number. That greater number is greater than the thrice of the number by 2. That means x is equals to 3y plus 2. Let that equation number 1. And in the second statement, 4 times of the smaller number, 4 times of the smaller number, that is 4y, is equal to greater number, it exceeds the greater number by 5, so that 4y is equal to x plus 5. Let it be equation number 2. Now solve 1 and 2 using any one of the 3 methods. I am taking here substitution method, so that by substitution method, by substitution method, (4y) is equal to, I can replace x by 3y plus 2. 3y plus 2 plus 5 is there. Therefore, transpose this 3y to the left hand side, then it becomes as 4y minus 3y is equal to 7. That implies that y is equal to 7. Y is equal to 7. From 1, we will get the x as 3 to 7 plus 2, that is 21 plus 2, which is equals to 23. X is equal to 23. And verification, need to verify. Verification. Are these two satisfy these relations or not? Substituting, because of we obtained that x equals to 23 from 1, automatically x and y satisfies the equation number 1. Now it is enough to see whether these two satisfies the equation number 2 or not. So that take equation number 2, 4 into 7 is equal to 23 plus 5. 28 is equals to 28 2. Therefore, the required numbers are 23 and 7. Next, come to the one more problem related to the money. Example 2. 2 tables and 3 chairs together cost 2000 rupees. Let me read the problem, and after that I will explain the solution. 2 chairs, cost of 2 chairs and 2 tables and 3 chairs. That means 3 chairs and 2 tables is given as rupees 2000. Cost of 3 chairs and 2 tables is equal to rupees 2000. And one more relation is also there, that is, whereas 3 tables and 2 chairs together cost 2500 rupees, cost of 2 chairs and 3 tables is equal to rupees 2500. Now requirement is cost of 1 table and 5 chairs, that is the requirement. I have to find cost of 1 table and 5 chairs, that is the requirement. Now to find the given requirement, first of all we have to find what is the cost of the chair and what is the cost of the table individually. So that solution. Let the cost of 1 chair is equal to, let cost of 1 chair is equal to rupees X. Cost of 1 table is equal to, cost of 1 table is equal to rupees Y. Now again, by the given data, need to establish the relations. Now see, 3 chairs and 2 tables is equal to 2000. You can, 3 chairs means cost of 1 chair is X rupees, cost of 3 chairs is equals to 3X rupees. Cost of 1 table is Y rupees, therefore cost of 2 tables is equals to 2Y is equal to 2000. That is given as 2000 rupees. Finally, left hand side is rupees, right hand side is also rupees, so that no need to write the rupees again. Here, next, from the second, let it be 1. From the second statement, what did you observe? 2 chairs cost and 3 tables cost. Total cost of 2 chairs and 3 tables. Therefore, we will get as the 2x plus 3y is equal to 2500. Let it be equation number 2. Children, if you observe, this problem is in special case. Why? Because of x coefficient in the first equation is equal to y coefficient in the second equation, and y coefficient in the first equation is equal to x coefficient in the second equation. If you observe that special case, then automatically those 2 equations can be solved very easily. Otherwise also we can solve it using any one of these 3 methods, but here bigger numbers are involving. Since bigger numbers are involving and there is a chance to apply this special case, we have to apply. Now add 1 and 2, 1 plus 2, we will get as 5 into x plus y is equal to 4500. Therefore, that implies that x plus y is equal to 900. 900. Now subtract 2 from 1, then we will get 3x minus 2x, that is x, this is minus y, is equal to minus 500. 2000 minus 2500, which is equal to minus 500. That implies that x minus y is equal to minus 500. By elimination method, we will get x is equal to add those two equations, let it be 3 and let it be 4, add these two, then y cancel. 2x is equal to 400, x is equal to 200, that is rupees 200, x is equals to 200, and after that we will write it again, x is equal to 200. Y is equal to 700. Therefore, we will get a conclusion. Cost of one child is equal to rupees x, which is equals to rupees 200. Cost of one table is equal to rupees y, which is equal to rupees 700. Now verification, need to verify whether these are correct or not. Substitute in equation number 1 those x and y values, substitute in equation number 1, that is verification. If you substitute, then what do you get there? 3 into 200 plus 2 into 700 is equal to 600 plus 1400, which is equal to 2000. Therefore, this is true. Now come to the equation number 2. Let it be 1, let it be 2. 2 into x, 2 into 200 plus 3 into 700, which is equal to 2500. Therefore, this is also true. Verified. Therefore, cost of one child is equal to 200, cost of one table is equal to 700 rupees. But finally, what is the requirement? What is the final requirement? We have to find cost of one table and 5 childs. Therefore, requirement is equal to cost of one table, that is y, plus rupees y plus cost of 5 childs 5x. Therefore, rupees, what is y? 700 plus 5 into what is x? 200. Therefore, totally 1000 plus 7, 1700. Therefore, the requirement is 1700 rupees. Okay, na children? Now we are going to see one more model also. Children, let us see the third model related to the fractions. Example 3. A fraction is such that if the numerator is multiplied by 3 and denominator is reduced by 3, then what is the first one? If numerator is multiplied by 3 then denominator reduced by 3. Denominator reduced by 3. This is the first statement in the given problem. One fraction is there. In that fraction, we have numerator and denominator. And one condition is given there. That fraction we don't know. That is the unknown. Finding of numerator and denominator. Those two are the unknowns to get that fraction. If numerator is multiplied by 3, then denominator reduced by 3. To find it, this is the relation. And one more relation is also there. That is, but if the numerator is increased by 8 and denominator is doubled, second condition. This is the first condition, this is the second condition. If the numerator is increased by 8, denominator is doubled. Denominator is doubled. And also given that in this case that fraction is equal to 18 by 11. Whenever numerator is multiplied by 3, denominator reduced by 3, then the fraction is equal to 18 by 11. That is given in the problem. In the second condition, if numerator is increased by 8 and the denominator is doubled, then we get the fraction as 2 by 5. Now, using these two, we are going to find fraction. So that in this solution, first of all, we have to take a fraction. Let the fraction be x by y. Two unknowns are involving there. One is in numerator, one is as numerator, another one as denominator. Now, according to the problem, first condition, whenever numerator is multiplied by 3, that is 3x. Denominator is reduced by 3, that is y minus 3, is given as 18 by 11. Now, from the second case, if numerator is increased by 8, that is x plus 8, and denominator is doubled, that is 2y, is given as 2 by 5. By solving these two equations, we will get x and y. Numerator we will get, denominator we will get, then we have the fraction with us. Now come how to solve these two equations. Cross multiplication from 1. Cross multiplication. 33x is equal to 18y minus 18 into 3, 54. From 2, we have 5x plus 40 is equal to 4y. Now, by follow any one of the known methods, we can solve these two equations. So that I am using here substitution method. From 2, make y as a subject and substitute here. Therefore, then we will get as from 2 y is equal to 5x plus 40 by 4. substitute in 1. Substitute 33x is equal to 18 into what is y? Y is nothing but 5x plus 40 by 4 minus 54. Now get cancelled. 18 and 4 get cancelled. There is a common factor 2 between these two. Therefore, after that, take 2 as the LCM. Then it becomes as 33x minus 9 into 5. Because of already I cancelled 2. 9 5s are 45x plus 9 into 40. 360 minus 2 into 54, 108 by 2 is there. Now it becomes as 66x is equal to 45x 360 minus 108, which is equal to plus 0 minus 10 minus 8 2, here 5 is remaining, 5, then 3 minus 1 2, 252. Now that implies that 66x minus 45x, what is its value? 66x minus 45, which is equal to 21x is equal to 252. Now find x value. Therefore, x is equal to 252 by 21, which is equal to how many times? 121, and after that 42 is there. Therefore, x is equal to 12. If x is equal to 12 from 1, we will get from 1 we will get y is equal to 25 by substitute x is equal to 12. Therefore, required fraction is equal to 12 by 25. And need to verify it also. What is that verification? Whenever 12 is multiplied by 3, it becomes as 36, and it is reduced by 3, then it becomes as verification. In that verification, once observe 12 into 3, 36 by 25 is reduced by 3, then it becomes as 22, which is equals to 18 by 11. Verified. First one true, first case. Second one, whenever numerator is increased by 8, that means it becomes as 20. Denominator is doubled, that is 50, then which is equal to 2 by 5. Therefore, this is also true. Therefore, children, in this aid number 6, we have learned how to solve the verbal problems related to money and related to fractions and related to numbers. In